In 1986, the shuttle Challenger exploded about 74 seconds after takeoff, killing all 7 astronauts inside. Or did it? It turns out that 6 of the 7 are still alive and kicking today. Ellison Onizuka claims to be his identical twin brother, Claude. Yeah, I've got an identical twin brother, Claude, too. The Challenger pilot, Mickey Smith, hasn't even bothered changing his name. He's now Professor Michael J. Smith of University of Wisconsin. Now, Krista McAuliffe was a bit of a sneaky one. She was the Challenger payload specialist, quite famous for being a teacher. It turns out during her astronaut days she was using her middle name, Krista, and now she goes by her first name, Sharon, and she's a Syracuse law professor. The Challenger commander, Francis Richard Scobie, is now Dick Scobie, which sounds like a rather unpleasant disease, CEO of Cows in Trees Limited. Judith Resnick, the Challenger mission specialist, again hasn't even bothered changing her name. She's a professor at Yale Law. And finally, Ronald McNair, another Challenger mission specialist, claims to be his identical twin brother, Carl McNair. What are the odds?
So there I was, just minding my own business, looking at Google Earth, and this big snow-covered monstrosity is staring me in the face like, why is that covered in snow? I look into Ireland and some other areas around it, Iceland. Ireland gets snow only once a year, 1 day a year. So I keep digging a little bit deeper, and I finally get underneath this cloud cover here, and a few images pop up. And I say, oh, images, what are they? Well, this is what you got, which I'm sure that looks familiar to you, right? Looks just like the pictures they give us of Mars. So I'm just kind of creeping around here and definitely noticing the same kind of undulation changes and same kind of rock, same kind of dirt. Only thing that's missing is that nice little red tint that they pay somebody $150,000 a year to put on there. But those mountains, those rocks, definitely exactly like we see on Mars. So I say, I wonder what they're doing out here. What is all this equipment for? I'm sure it can't be NASA, right? Whose orange Hummer is this? Okay, that looks like a NASA symbol. Well, let's dig a little further because I can't really see anything on here other than it certainly looks like a NASA symbol. And I can't read that. Tried. So this one here said roving the Arctic. So what is that? Doesn't make any sense. Pop in here. See if we can find anything. Again, same kind of mountains. That looks like the same kind of water I've seen before that I thought was water on Mars. Who knows? Zoom in. What's that? Oh, nothing. Just looked like it was funny. So I'll keep kind of going through here and see if it... What the... Yeah. So, I think I found out where Mars is, guys. It's just about 1,000 miles north of me. Not quite the distance that NASA says, but I can't find anybody who's in charge of this. They must be hiding behind these rocks. Oh no, there they are out in front of everybody, just standing there. Lovely. Clown number 1, clown number 2, and clown number 3. Yeah, this is very empty here. Oh, there's one of those ATVs. All right, now we're on to something. Oh, I got another truck. Oh yeah, it says NASA. What's that say? Mars Project?
No, not one picture of the Earth. Imagine that. Thousands of satellites supposedly orbiting the Earth. Why can't we get thousands of pictures? One shot with the whole Earth in it. We should have a channel on cable that shows the Earth rotating 24 hours a day, every day. Nope. Let's listen to NASA's very own Robert Simmons talk about how we get our fake pictures of Earth.
Last week, scientists at NASA released this. The shot is compiled from data from NASA's WIERZŞ instrument, which orbits the Earth about every 100 minutes, taking measurements of light coming off the planet. That can be translated into ribbons of imagery like this, and then into one of these. And this is just the latest in NASA's Earth from Space album, which may be one of the most mind-expanding collections of images in human history. And then in 2002, Blue Marble 2.0, NASA's Rob Simmons made this. Simmons' job is...
It's primarily taking data and making pictures out of it.
That's what this is, a composite of data sets from several different instruments translated into a picture.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it was a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command Z a lot.
There's artistry to creating the world.
What I imagine it to be. Unfortunately, I'm not an astronaut. I've never been to space. But I've looked at these images over and over again, trying to sort of get the essence of it. It is photoshopped, but it's has to be. It is photoshopped, but it's has to be. It is photoshopped, but it's has to be. It is photoshopped, but it's It has to be.
This next-generation spacecraft will enable America to explore beyond low Earth
The
orbit.
kinds of technologies that we're testing out on Space Station are definitely helping us with our goals of going beyond low Earth orbit.
Early in the next decade, a set of crewed flights will test and prove the systems required for exploration beyond low Earth orbit.
Plan that NASA has is to build a rocket called S.O.S, which is a heavy lift rocket. It's something that is much bigger than what we have today, and it will be able to launch the Orion capsule with humans on board, as well as landers or other components to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the farthest that we can go, and this new system that we're building is going to allow us to go beyond and hopefully take humans into the solar system to explore. So the moon, Mars, asteroids, there's a lot of destinations that we could go to, and we're building these building block components in order to allow us to do that eventually.
We are headed 3,600 miles above Earth, 15 times higher from the planet than the International Space Station. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space. We must solve these challenges before we send people through this region of space.
NASA admitted that it had lost the original footage of man's first steps on the moon.
YouTube and watch A Funny Thing Happened on the Way to the Moon. It contains newly discovered evidence, which is part of the missing tapes, of outtakes from the first mission to the moon, of them falsifying a shot of being halfway to the moon. We found never before seen footage of them faking part of the photography, which is in A Funny Thing Happened on the Way to the Moon, which has been licensed 5 times and can only now be viewed on YouTube.
Here they discuss the fact that they have turned out the lights and have blocked out sunlight from entering the spacecraft through the other windows, as to not cause any reflected light to fall onto the spacecraft's wall in the foreground.
Okay, very good. Well, we shut out the sun coming in some of the other windows into the spacecraft, so it's looking through the number 1 window, and there isn't any reflected light.
The reason this was done is so that the truth of the matter would not be revealed. It is this. Though the federal government would have you believe that this is a view of Earth from a distance out of the spacecraft's window as it nears the moon, it is not. What they have ingeniously done is placed the camera at the back of the spacecraft and centered the lens on a circular window in the foreground, outside of which it is completely filled with the Earth in low orbit. The circumference of the window then appears to be the diameter of the Earth at a distance. As they perfected the shot, a crescent-shaped piece of black material was inset slightly into the window to create the illusion of the Earth's terminator line dividing night and day. It is uncannily convincing. During this segment, intended to be edited and played back later for the worldwide television audience, dated July 18, 1969, Neil Armstrong condemns himself as he states that he is 130,000 miles out.
Roger, Houston, Apollo 11. Calling in from about 130,000 miles out.
Finally, the iris is opened up and you can see the real location of the camera and the very bright and near Earth out the window. Here is the slate for the 19th of July, and the same shot of trickery on the 19th of July, and then the 20th, and the same misleading shot on the 20th. Later that evening, they were said to be walking on the moon. How can this be when they were in Earth orbit only 9 hours earlier, and the moon is some 3 days' journey away?
So I took a year and I traveled across the country, and folks, I've actually posted it on YouTube. It's called Did We Go? And the challenges, Geraldo, everywhere I went, it was just amazing. Moon rocks falling in Antarctica, Neil Armstrong's silence. But I was the first to report, and you played the clip earlier tonight, that all the science data, the telemetry data was missing. Now, Geraldo, for NASA to come out and say that all the tapes were erased, I mean, it's incredible. Geraldo, this isn't just one tape. This is rooms of tape labeled Apollo 11 moon landing. Someone had to physically go and erase it. It's very challenging to try to prove we landed on the moon, and it shouldn't be challenging. The tape should be there. There should be plenty of evidence.
From an analytical standpoint, photographic anomalies have to be sought out with an understanding of lighting and shadows. The most straightforward is simple. When objects are lit solely by the sun, as all the scenes on the moon were said to be, after all, lighting equipment was not only impractical, it was unnecessary in bright sunlight, then all shadows, regardless of the landscape, will run parallel with one another and never intersect, as shown by this example. In these seldom seen photographs, obtained from a rarely used auxiliary NASA archival site, it is clear that these scenes were lit with artificial light. These shadows, which are cast at different angles, are evidence that a second light source is being used. In addition, the sun would not cause an isolated hotspot like this, only an artificial light would. Again, intersecting shadows and another hotspot. And again. And again. It is simply impossible for this picture to have been taken with sunlight on the moon. Here, the shadows are shown to be as black as pitch. And yet here, completely in a shadow, the astronaut is lit up like a Christmas tree. How can this be? Or this, on the shadow side of the lunar module. In this magnification of an Apollo photograph, a rock, very likely a papier-mâché prop because of the crease here, is categorized with the letter C. In later releases of the same picture, the letter is gone, probably airbrushed out. Here, a crosshair, which was burned directly into the image from the film plate, and thus should always appear on top of the objects in the photograph, appears behind the object in this scene, clearly revealing a composite of two pictures into one. Someone apparently forgot to create a burn crater underneath the lunar module's 10,000-pound thrust engine, despite the fact that during ground tests there was a real concern for the vehicle falling into the hole the engine created as it descended. Here is a depiction based on the latest specifications and scientific data. In these enlargements, it looks as though the lunar module was simply placed there. Not even one speck of moon dust on the landing pod. As a result, all subsequent flights had to have the same discrepancy, which was explained away by the effect of no atmosphere. And what about stars? On the moon, with no atmosphere, they must have been quite a sight to behold. Yet there is seldom any mention of them, if ever, by any of the astronauts on any of the missions. Undoubtedly, creating a mural with all the constellations properly placed in the sky would have been virtually impossible to create accurately, much less realistically. A competent amateur astronomer would have been able to call attention to the slightest error in measurement. The answer? Not to talk about the stars, ever.
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics. I don't recall during the period of time that we were photographing the solar corona what stars we could see.
I don't remember seeing any.
The sky is a deep black when viewed from the moon, as it is when viewed from cislunar space, the space between the Earth and the moon.
And we cannot see stars.
It's not a black void. I mean, it's black, but there's all kinds of little polka dots.
There's all the stars there, and the cool thing is about it, you can see it during the day.
And when you're in space and you're looking into deep space and you're on the sun side of the orbit, the sunlight washes out all the starlight, so you can't see any stars, just like here on Earth.
There's all the stars there, and the cool thing is about it, you can see it during the day.
Yeah, you can, and there's more than stars. You can see planets. You can see moons.
You see the gas Magellan clouds of the
you
Milky Way
see
galaxy.
the Magellanic. The sunlight washes out all the starlight, so you can't see any stars, just like here on Earth.
Pretty much all the time you can see the stars.
Then when you look out into deep space away from the sun, it's the darkest black you can imagine.
Pretty much all the time you can see the stars.
You would think there are rules on the International Space Station. For example, be careful with water next to electric devices. Their life depends on it.
And I thought I'd show you how I do it. Let's see. To get started, these are the things I need. A bag of warm water, a little no-rinse shampoo, towel, and my comb. What I like to do is start by just putting some hot water, squirting it onto my scalp. And I have a mirror here so I can kind of watch what I'm doing. Sometimes the water gets away from you, and you try and catch as much as you can.
Here I am, and I got my water. So first of all, I'd like to show you how water behaves in weightlessness, which is kind of interesting. Of course, it doesn't fall down like it does on Earth, and it kind of tends to stick to your skin because of surface tension. I don't know if you can see it. See, it doesn't really want to move away from your hand, just because of that surface tension effect.
We have power bricks. You see all these things, this blue bricks for power supply.
Just because it's a little bit difficult to control.
So water is also very dangerous on the space station because we have a lot of electricity. So we need to be very careful not to spill it.
It's getting nice and wet. I want to make sure for the experiment that it's really soaking wet.
Water is also very dangerous on the space station because we have a lot of electricity. So we need to be very careful not to spill it.
Okay.
So we need to be very careful not to spill it.
So I have a soaking wet washcloth here floating in front of me. Oh, there's one ball of water floating around. I'll put it on the washcloth. Okay.
So we need to be very careful not to spill it.
So here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out. Right? It's really wet. It's becoming a tube of water.